What's the most dangerous job in Britain? Well, think of the industries. Chemical, construction, mining. Well, in fact, it's none of those, not even close. The most dangerous job by a mile is catching fish.
Fishing is a very dangerous industry. Your foothold's shifting, it's usually wet, there's water coming in, so you've got an unsteady onshore base, and then you've got a lot of moving equipment, wires, warps, gears, heavy fishing gear may be swinging because the boat's swinging. It's an extremely dangerous, hazardous occupation.
It's not hard to see why. This can be a hostile environment. But fortunately, the fishermen aren't alone out there. As well as the water, they're surrounded by another ocean, a sea of invisible waves. Radar and radio are just two of the waves these fishermen depend on. Without them, they'd be lost. This is the story of the science of waves, waves that save lives. I've come here to Looe in Cornwall to set a challenge. Can two skippers take a trip back in time and do without the modern electronic gadgets their fishing boats rely on? Why? Well, I'm going to explore with the trawlermen the science they depend on for their livelihoods. And if the worst came to it, their lives. It means getting to grips with the ups and downs and ins and outs of waves, from the ocean to the invention of radio, from shouting to the structure of the universe. The connections will be revealed. Right, time to meet the skippers. Armand Toms and Neil Murray are our two volunteers. I caught up with them on a rare day off. Neil, hi.
Hi.
How are you?
Fine, thank you.
You're going to come and have a chat with me then, Armand?
Well, then.
Now, you fish by pair trawling, is that right?
Yes, that's correct.
What's pair trawling?
Pair trawling is two boats towing a large trawl between them. Bigger net is better for two small boats to tow together. It's more efficient and helps us compete with the bigger boats because we haven't got the power.
You have to make sure that both boats are working together, that they're coordinated, the strain is equal on either side to keep the net square and fishing efficiently. It's a very skilled job requiring a lot of cooperation. Certainly good communications between the two boats.
When we finish one haul, we all up and it goes aboard one of the boats while the other one shoots its net. And while you do your second tow, you pick the fish up, you gut it, braid it, wash it, put it down below and pack it in ice, ready for coming in and offloading onto the market.
I think fishermen find it very hard to imagine what it's like for the families left at home because they're at sea, they're busy, they're fully occupied, they know perfectly well they're safe, there's nothing wrong. For the family at home, it is a very long, anxious time. I don't think there's any other phrase for it. There's a permanent sort of anxiety, permanent concern. Will the husband be coming home? Will the father of the children be coming home?
Nobody actually who doesn't know the commercial fisherman doesn't actually appreciate what being in that sort of job entails. It's something that's in their blood. It is a very dangerous occupation. Nobody can actually determine what the sea is going to do and determine what the natural elements are going to do.
It's very exciting at times and lonely at other times. Never knowing what time they'll be back or worrying, knowing what the weather can suddenly whip up a storm and if they're safe.
I've come to accept it over the years that I know he's not going to take any unnecessary risks. We've now got mobile phones, so we can keep in contact.
Half an hour after that will be home, okay?
You need communications that are going to work when the chips are down. And a mobile phone may be very handy, and you can ring the wife or your friend at the pub and say, get a pint up for me at 5 o'clock, but it doesn't replace the ship-to-shore radio telephone, the proper kit.
263998.
Ship-to-shore radio telephones are run professionally. Shore stations are monitoring for distress signals. Certain channels are monitored all the time.
Well, firstly we have the VHF, and we communicate with other fishing vessels. We also listen out to the Coast Guard for the weather reports. It's very important for us because we're pair trawling, so we're constantly talking to Armand on the other boat.
So how do you make sure that you and Armand keep a constant distance apart when you want to?
We use the radar for that.
So is that blob there Armand?
Yes, I'll go on there now.
That thing over there, GPS, that's a good one. Global Positioning System. It receives messages from satellites 18,000 kilometres away to tell you exactly where you are. The sounder works underneath the boat and can help you detect shoals of fish. Kind of important, that one. The radar sends signals out from the boat and helps you stop bumping into things. The navigator works like the GPS, but from a ground station instead of satellites. And the track plotter plots exactly where you've been and where you're going. And last but definitely not least, an essential piece of kit for all fishermen. A TV, so you don't miss neighbours. Different gizmos, but they all have one thing in common. They all work by sending or receiving waves.
Well, out on the trawler, the most obvious waves we can see are the water waves, like these ripples out here on the lake. But as far as the trawlermen are concerned, perhaps more important, at least for their safety, are the invisible waves, the waves we can't see, like the radio waves, which are used in their global positioning system, in their communications equipment, and in their radar. And then there's the sound waves used in their sonar for detecting fish, but once again, they're invisible, so it's rather difficult to really see what's going on.
If we're going to get to the bottom of the invisible waves these guys used to communicate, let's get back to basics. Neil's going to turn all these gadgets off so that we're deaf and blind, alone. Now they're going to have to make do without the technology and do things the old-fashioned way. Ivan Chaston has spent a lifetime at sea. He's retired from fishing now, but keeps his hand in running the ferry between East and West Looe. Ivan and his friend Lewis Butters remember the way they used to share news of a good catch.
You'd have a bit of rag if you hold your trawl up.
Oh, yeah.
You had 10 stones, say, of fish. When the other boat was coming close to you, you have a bit of rag and wave 10 times.
Or your oilskin.
Or whatever amount of fish you had, you know, and he'd wave back and say what he had.
Well, sometimes in daylight you either wave your oilskins to attract our attention, or you have your sail, what we call a mizzen, and lower you up and down, things like that. In night time you'd either blink your lights, or you put up an old flare. You'd have like an old tin, then you'd have like a, how can I explain it? Like a mop,
yeah.
You know, and he'd be soaked in paraffin or stuff like that, and you light it up and put it up.
There were many ways of signalling to another boat, but in the days before radio, if you wanted a chat, the only way to do it was to shout. Right, well, if you're going to give up your radios, we'd better test out your lung power. Go on then, off you go.
Can you still hear me?
Plain as day. You get me, Neil?
Yeah, I'm getting you. Are you still getting me?
I'm getting you fine.
So they're not using radio waves to talk now, but they're still using waves, sound waves.
Yes, I'm still getting you, Neil.
The problem with sound waves is that they spread out in all directions, so the further away you are, the fainter the sound is. Also, sound gets absorbed in the air, and if you're outside, then the wind blows the air around and the sound's even harder to hear.
Can you still hear me now?
You're getting fainter.
So are you.
You're going to have to start shouting.
While they get on with shouting at each other, let's talk sound. Sound waves are really hard to see, but the way they work is a lot like this slinky. Imagine for a moment that these slinky links are individual air molecules. If I put in a bit of oscillation at this end, you can see the energy travels down to the other end of the spring as a wave. And that's how your voice works. When you speak, on a tiny scale, the air molecules push into their neighbours and then bounce back. And so your voice travels through the air like a compression wave.
As I'm talking now, I'm producing a sound wave. That's a compression wave in the air. But what is a wave? Well, a formal definition is that it's a periodic or regularly repeating disturbance that transports energy from one place to another. And a sound wave is a so-called longitudinal wave. That means that the variation is in the same direction that the wave travels. Now, sound travels fine through air, but it travels even quicker through solids such as metal. That's why if you're in a tube station, you'll hear the sound of the train coming along the tracks before you hear the sound through the air. So perhaps one way our fishermen could do better is with the old tin can telephone. You speak into one end, the sound wave travels along the string and is heard at the other. But maybe that's not too practical out at sea, so our fishermen will have to think of something a bit better.
The aids to speak at sea basically were only a tin trumpet. I mean, apart from the voice itself, the tin trumpet would focus the sound and help it carry over the water a bit better than just a straightforward shout.
Is that any better?
Yes, that's better.
One way to make shouting work better is to use one of these. There you go, Neil.
Thank you very much.
A loudhailer stops the sound energy spreading out all over the place and pushes it all only in the direction that you point it.
Can you still hear me now?
Yes, I'm still getting you, Neil.
Are you getting me now?
Yeah, I'm getting you, Neil. We're going to drop it across, see how far apart we can get.
The problem with shouting between boats is that you've got a lot of noise going on in the background. There's the wave noise, there's the wind noise, and there's just a question of whether you really understand what's being said and whether you hear it properly.
Still getting me, Neil.
We're just about on the limit now.
This loudhailer technology does have its limits. I don't think it's quite up to the job, really. Neil, what do you reckon?
No, it's hard on the voice, and also we're quite close together, so we need to be a lot further apart to do the job that we're trying to do today.
So this distance here, what are we, about 100 yards, 150 yards, no good for working?
No, not at all.
Well, they can just about talk to each other, but there's no way they can talk to land. Now, you might think that that would have been scary, but it made the captains all powerful.
The authority of a master mariner was always summed up as master under God, and that was a very real positive expression. The only one person between you and your maker at sea was the captain, and whatever he did and decided affected you materially. If he made the wrong decision, then the ship may be wrecked and you went to your maker.
We never had no Willis's when we first started. No echo sounders, just as he said, just a compass. Follow the birds and look for the signs. Colour of the water, daytime, bubbles, fish coming up, things like that.
When you're out at sea, you've got periods of time when you're not working. You've got moments of contemplation, and you tend to look out at the immensity of the sea and the huge sky and maybe the stars, and you just wonder how it happened, how it came to be, and how do you fit in this little dot in eternity.
On occasions he's been out on his own, which I really don't like, obviously for safety purposes, and I'm always saying to him that he must, just so he doesn't fall asleep or anything, that he must keep in contact, if he isn't pairing, but always on the radio with other people. And I will phone him quite often if he's out on his own.
Countless generations of mariners braved the perils of the sea with only their shipmates for company. But thousands of years of isolation changed in just a few short decades, when in 1897 the first radio communication was sent over water across the Bristol Channel. This revolutionary form of communication used a mysterious new type of wave.
In the early years of the 19th century, people like Michael Faraday and Joseph Henry were doing experiments with electricity and magnetism and showed that the two were linked. Then in the 1870s, a Scottish scientist, James Clerk Maxwell, showed that they were really just two parts of the same thing. And he showed that electromagnetic waves could exist, transporting energy from place to place via electric and magnetic fields. It was only after his death that Heinrich Hertz produced these radio waves, and not until the 1890s that Marconi showed there was a real use for them. And indeed, radio waves are now the basis of our whole communications industry.
In the early days of radio, it wasn't speech that was transmitted, it was Morse code. In 1910, the world became aware of the power of the wireless at sea with the arrest of the notorious criminal Dr. Crippen. He fled England by boat after parts of a woman's body were found buried in his coal cellar. The police, informed of his progress by radio, raced across the Atlantic and arrested Crippen and his companion, a woman disguised as a boy. Marconi's invention was headline news.
Radio seemed like magic. It could send messages fantastic distances between continents and beyond. To do that, radio waves must obviously be very different to sound waves. I mean, I can't shout to America from here, but I could send a radio message.
A message that would be carried by electromagnetic waves.
There's a link between electricity and magnetism. In fact, a changing electric field generates a magnetic field, and a changing magnetic field generates an electric field. And that's what an electromagnetic wave is. It's a self-propagating, changing electric and magnetic field. Now, whereas a sound wave is longitudinal in that the oscillation is in the same direction that the wave travels, an electromagnetic wave is a transverse wave. The oscillation is in one direction, but the wave travels in a perpendicular direction to that. And that's rather more like these water waves.
In an electromagnetic wave, the electric and magnetic fields vary together, oscillate up and down in sympathy. You can't see it, but energy passes from the electric field to the magnetic field and back again. A radio transmitter sends out oscillating electromagnetic energy into space, like the ripples on a pond or the waves on the sea. The energy in a water wave can travel across the oceans. Well, the same's true of an electromagnetic radio wave, but it can also travel out across space.
Although electromagnetic waves travel in a similar way to other waves like sound waves or water waves, there is one important difference. Now, water waves require a medium to travel, that's the water. Sound waves also require a medium like air, but electromagnetic waves don't require a medium. They can travel through empty space, through a vacuum. And that's why we were able to send and receive radio messages to astronauts on the moon.
It's one small step for man, one giant leap for mankind.
For Marconi, getting a message across the Atlantic was the equivalent of talking to the moon. His transmitter was set up down the coast here in Cornwall at a place called Poldhu. 2,170 miles away on the other side of the Atlantic, Marconi's makeshift receiving aerial was a cable held aloft by a kite. Despite a howling gale, he managed to get it 100 metres into the air. And to everyone's astonishment, except Marconi's, it worked. England spoke to America wireless for the first time on the 12th of December 1901. And the rest is history.
There was a strong push to get radio at sea because of the total isolation of ships. It was probably more the merchants and the owners who wanted it than the captains, although there was obviously many reasons why a radio would be useful when you're at sea, in emergencies, and etc. But many captains resented their loss of independence. The moment radios were effectively available, then the owners could issue commands at any time of the night or day and tell the skipper what to do. But it also meant that wives at home could listen in for the first time to the messages their husbands were sending.
I've got it fixed up in the kitchen and I can listen to all the gossip. He'll even say to his friends sometimes, can't say a lot today because I think we've got ears. But on the whole, it's nice to actually listen to, even if it's the other fishermen and not Neil, that I can hear. It makes you feel closer than you perhaps were before.
So it's time to put our skippers out of their misery and give them back their radios. But we're not going to make it quite that easy, no plain sailing here, because Neil and Armand are about to follow in Marconi's footsteps by making their own wireless, a radio stripped down to the bare essentials. And believe it or not, chaps, you have got everything here you need to build a radio. You've got your instructions, you've got the bits and pieces. Are you okay to do that?
We'll give it a try.
Yes?
Yeah. Are you sure everything's there?
I'm sure.
It doesn't look much.
We'll see what you can do with it.
Okay.
All right, I'll leave you to it.
Right, where should we start?
Start with that bit there.
The two basic components of any radio receiver or transmitter are just a simple coil like this and a variable capacitor like this. A coil of wire can store energy in the form of magnetic energy within it, whereas a capacitor can store electrical energy.
And it needs 100 turns.
Now, if these two are connected together in an electrical circuit, then as the electrons oscillate backwards and forwards between the two, energy will be transferred from magnetic energy to electrical energy and back and forth. And that's really the basis of any radio receiver or transmitter.
Yeah.
Adapter, and then the black is going to go to the black on the other
The variable capacitor lets you change the capacitance in the circuit, and that lets you change the natural rate at which the electrons oscillate backwards and forwards. And that's what we mean by tuning in a radio.
I've only come back to where I was before, so I've got all this way to go yet. I can go slowly.
Nothing at all.
No. Well, if you like to hold on to that one and try and tune it, I'll take the aerial, unravel the aerial.
Now, it may surprise you to see that our two fishermen don't have a battery in their radio. That's because in a simple radio circuit, you can actually extract all the energy you need from the radio signal itself. But to do that, you need a very large aerial, and they'll need a long piece of wire to pick up enough energy to drive their radio circuit.
So what's the big deal about waves? Well, waves aren't just important to our fishermen. Waviness is crucial to the way nature works. Sound, radio, water waves. What's the connection? What is it about these periodic oscillations, these waves, that makes them crop up everywhere?
Waves tend to crop up all over the place in nature whenever energy is transported from one place to another, whether that's as a water wave, a sound wave, or an electromagnetic wave. And although these waves are quite different in many ways, they do have one feature in common, and that's in the way we characterize them in terms of their wavelength and frequency. Now, the wavelength of a wave, like these water waves here, is just the distance from one peak to the next. So for these water waves, it's about 10 or 15 centimeters. The frequency of a wave, that's the number of cycles that pass a given point in a fixed length of time. So again, for these water waves, 2 or 3 waves are passing by every second, so that's a frequency of 2 or 3 hertz.
Hi Armand, how are you getting on?
Fine.
Has Neil given up on you?
No, he's
How's he gone?
out in the garden running up the aerial.
Oh right, so is it working?
Yeah, working fine. Radio 5. Radio 5.
I can't hear anything on your account, but I've brought an amplifier with me so I can listen in to what you've got. Let's have a go. Let's take that on there.
And very kind of regal, and I'd like to get one as well if there's
Very
okay.
good.
Number 1601.
I'm impressed. Radio 5 Live.
Is that any better?
Yeah.
Yeah.
Lovely.
Yeah, listen.
Good food magazine, and I'm sure
Oh,
quite a few
great.
of these Christmas
Well
I'm
done.
impressed.
A little bit later on, maybe after the programme's finished. It's 5:30. The news headlines next.
Of course, radio isn't just used at sea, it's used everywhere. And there's more to electromagnetic radiation than just radio waves. In fact, there's a whole spectrum of radiation. All the same sort of thing, but different in that it has different wavelengths and different frequencies, such as you see on a radio dial. As I go through the frequency spectrum here, from low frequency through to high frequency, I go through a whole spectrum of radio stations. And if I went to higher and higher frequencies, I get to TV broadcasts. and eventually to microwave signals used for cooking your dinner or in mobile phones.
While we're at it, a quick guide to wavelengths. Radio waves can be hundreds of metres or just metres. TV, well, that's about a metre or so. Microwaves are only centimetres. And after that, it all starts to get very, very small.
And at higher and higher frequencies, shorter and shorter wavelengths, we come to infrared radiation, heat. And at shorter wavelengths still, we get visible light. Light all around us is just electromagnetic radiation with wavelengths of less than a millionth of a metre. And further on still, we get ultraviolet light.
Yep, light is an electromagnetic wave, just like radio, only of a fantastically shorter wavelength. And it doesn't stop there. Go for even shorter wavelengths and you get X-rays, even gamma rays. Many names, but still the same thing. Electromagnetic waves, an infinite spectrum of radiation. And that wavy electromagnetic radiation is quite literally everywhere.
In fact, the universe contains about 1 billion times as much electromagnetic radiation as it does matter. We tend to think in terms of material objects because we're made of atoms and molecules. But even in the empty vacuum of space, there may be no matter, but it's full of electromagnetic waves. Starlight from the stars, the cosmic microwave background left over from the Big Bang, and in many ways, the stars, planets and galaxies are just surrounded by a sea of electromagnetic radiation, just as our two fishing boats are surrounded by a sea of water waves.
Heavy showers falling as snow in many places from Northern Ireland through into Scotland. Cold across these areas too in that strong wind. Temperatures only about 5 to 7 degrees. But then through tonight we start to see the winds picking up again ahead of this next system. Heavy rain already into northwestern parts by dawn tomorrow, moving on across all areas, I think, during the second half of the day. Ahead of that, 1 or 2 spots in the east, perhaps dipping.
So there you have it. We're all surrounded by an ocean of waves. Just for some of us, it's more obvious than others. But even if you don't go out to sea, there's sound, light, heat, radio, television. We're all in contact with a universe of wave energy. But fishermen rely on that contact for their livelihoods and sometimes their lives.
Well, like I said, the old man used to say, look after your worst enemy out to sea, because you never know when you're going to get in trouble yourself. Out to sea, you got to have somebody who gets in trouble, you know. Then look on the land, you can't get out of a boat and walk in.
At the end of the day, men going to sea will be alone there and then. At the moment you're there, it's up to you how you cope with the situation. This reality, this will never change.
Today, I think too much modern equipment has ruined the fishing. Made it too easy. That's my way of thinking, anyway. And the fish won't stand it. Well, I don't know what you think about it.
Best of luck to them. I mean, they're still out there against the sea today. They got more modern aids to help fight it, but they're still against the sea now. Well, there's still boats being lost with all the modern equipment, isn't there?
Yeah.
You know.